Hello, and welcome to the episode of ES Repair. I am your host, Mr. Fix-It. In this video, we'll discuss the MOSFET, Metal Oxide Semiconductor Field-Effect Transistor. And we'll be talking about the different types there are, and the different usages they have, and finally, how to test them. So let's get started. Here we have Metal Oxide Field-Effect Transistor, also known as MOSFET. Now, those of you who have been working on your amplifiers and things like that, you've probably came across these. I've had people writing into me asking about how do you test these. So, here you are. Now, we're going to talk about two different modes. We're going to talk about the depletion mode and the enhancement mode, as you see here. The depletion mode means that the transistor is conducting current between the drain and the source by default. In other words, you have to apply voltage to the gate to turn them off. Enhancement mode is the opposite. By default, no current flows between the drain and the source. You must apply a voltage to the gate to turn them on. Now they are available in two different types, the N channel and the P channel. We'll be working with an enhancement mode N channel MOSFET known as the IRF 510. Now these are similar to JFETs, but they're also different. JFETs had a connection between the gate and the channel, whereas the metal oxide field effect transistors have a very thin film or layer, which is kind of like a glass layer of silicon oxide or metal oxide between the gate and the channel, and it insulates it. Now, because of this very thin layer, these transistors are very vulnerable to static electricity. Now, I will show you later in this video as we move on how sensitive these things are to static electricity. Now, these things are very useful because the current is very little. We're talking about microamps or nanoamps. So these transistors can be connected directly to the integrated circuit without any effect whatsoever. And these pretty much have an infinite resistance between the gate and the channel. Now you can use these either as a switch, or you can use these as a voltage controlled variable resistor. And believe it or not, these can be used in amplifiers. Now you also have power MOSFETs, which can handle a lot of current. And I'm going to show you one in a few moments. Now you'll see that the MOSFETs can switch very high currents because they have such a low on-state resistance, and I'll show you that too. So first we're going to get the transistor connected. My first pin is my gate, the second pin is the drain, and the third pin is my source. Now the current will go from the drain to the source. Now be careful because some of these transistors do have a diode in reverse bias. This is to protect the transistor from inductive loads such as those created by motors. So you want to make sure that you replace them exactly. So let's get started. Here I have my board set up to demonstrate the MOSFET transistor. Now, as you can see, there's no resistor. This makes them really good to use when high current is in demand, because there is no current that goes to the gate, only voltage. And it requires no more current than what an integrated circuit can provide. So this makes them really, really useful for direct connections to integrated circuits, such as a 555 timer chip. Now, you'll notice there's no resistors. I've got this red wire standing up because I'm going to demonstrate something shortly. I've got my power supply hooked up. I've got my alligator clips going to my light bulb right here. Now, as you can see in its current state that the transistor is turned off because my light bulb's not glowing. These transistors, this one specifically, is an N-channel MOSFET. That means that this transistor requires a charge to turn it on. This is known as enhancement mode. Depletion mode refers to the transistor is already on, but needs a charge to turn it off. Now, for the N-channel enhancement MOSFETs, you require a positive charge to turn the transistor on. Now, these transistors are so sensitive that in order to work with these, you've got to have an anti-static wrist strap to help discharge any sort of static buildup that you may create. And as you can see, the alligator clip here is connected to the ground to dissipate any static electrical charge that I may produce. Now, let me show you what happens and show you how sensitive these transistors are. I'm going to remove my ground, and I can touch the wire just with my finger. And see, I can turn the transistor on. This means that I'm having enough static buildup to turn the transistor on. Now, if I was to hook that back up the ground, I don't have that problem. Man, I could just sit here and rub the floor and still touch it. Nothing happens. I can't turn it on. But if I remove it and I can build up electricity, static electricity, look what happens. The gate turns on. This is the thing about static electricity you have to be careful with, because it can destroy the MOSFET. So let me turn that back on, connect that back to my ground. Now, notice the light bulb is still on. The reason for that is because since these transistors use a metal oxide film to insulate the gate from the channel, it creates a sort of capacitance. And this capacitance, like capacitors, will store charge. And depending on how much charge there is in the gate, it can take a while for the charge to dissipate. Well, all you have to do on this transistor is ground out the gate like that. And now the transistor is turned off. Now, because I got my wrist strap still grounded, I can go back and touch it and rub the carpet and nothing will happen. This is the best way to protect these. So if you're going to be working and testing with this MOSFET, be sure you got a anti-static wrist strap connected to a ground to help dissipate any kind of static charge you may have. Especially if you're going to replace these. If you, after this test and you find you have a faulty MOSFET, when you install the new one, you still need to take the precautions to avoid static electrical buildup. Now, another thing that these transistors are good for is switching. They have all kinds of switching capabilities. These things can switch from off state to on state and vice versa within 8 billionth of 1 second. That is very, very fast. That's faster than a blink of an eye. Now I'm going to add this 330 ohm resistor to the gate. This is the only thing the resistor is used for, as I will demonstrate. Let me plug in my red wire again to the gate. Now, remember when you touch the red wire to the positive? See what happens? If you touch the positive, the light comes on. But as soon as you remove it, this resistor discharges the charge out of the gate, forcing the gate to turn back off, or turning the transistor back off. This is what the resistors are used for. They only dissipate the charge that's built up in the transistor, so the transistor can turn off. Now, another thing that you can use these transistors for is amplification. Not only can these transistors be used in switching due to their very high speed switch capabilities, they can also be used in amplifications. I'm going to hook up this variable resistor and show you how you can control the voltage. Now, these are mostly used for high-speed switching, such as those in power supplies. Well, I'm going to show you how these can also work in amplifications. Now, you can control the voltage. If I was to turn the voltage in one direction, hold that in place. See, I can make the light come on. Now if I turn it the other way, I can actually control how much current goes through the transistor. I can have a little bit of current go through, or I can increase the current to go through. Back and forth. Now it requires very, very, very little current. We're talking about nanoamps to microamps because of the gates not directly connected to the channel. I can do it linearly or linear. And that's how these can be used as amplifiers. Now I'm going to show you the resistance when these transistors turn on. Now this is the reason why these transistors are highly used in amplifiers and switching power supplies. Now as you can see, the transistor is currently off. I have my test meter zeroed to remove the resistance that runs through the probes. So when I turn this on, watch the resistance. Notice how low it's going? Not even an ohm. Now, because the transistor is in its on state, let me plug that back in. you'll notice how low this resistance goes. We're talking about a half of 1 ohm. This is why they are highly used for high-speed switching, because these transistors can handle a lot more current than a bipolar transistor can. Plus, this allows them to produce less heat. The less the resistance, the less heat that is produced when their current is flowing through the transistor. And this is pretty much how these transistors work. Well, that concludes this video for MOSFETs. I hope everything was informative for you. You learned how to test MOSFETs and the different types there are. Be sure to vote to let other people know if you liked it or disliked it. Leave a comment if you have any, or you can contact us personally if you have any questions. I'm your host, Mr. Fix-It. Thank you for watching.